Ciao everyone, and welcome to a new episode of the Superhuman Podcast. I am your host, Renato Capasso, and together we will talk about the latest biohacks and scientific discoveries that will turn you from a human into a superhuman. And it all starts now. Hey there, so today we're gonna have a great episode. My interview today is Liz Parrish. She's the CEO of a company called BioViva, but the cool part about it is that we're gonna talk about one probably of the greatest biohack out there. And I'm talking about gene therapy. Yep, you heard it right. Gene therapy. How to biohack your genes for better health, for potentially reversing aging. So just so you know, she had a gene therapy for two particular genes. I don't want to tell you more. I want you to sit down, relax, and enjoy the episode because this is going to be a very, very cool one. And it's going to be giving you a very light of hope for those who want to live forever. Enjoy the episode. How are you? Oh, it's such a pleasure to see you and to have you here. Like I'm very so happy.
Thank you. I'm happy to be here too. I mean, here we are, 2020, trying to have some progress and some fun at the same time.
Yeah, that's good. 2020, such a year, hey? It was such a year, this 2020. Okay, I'm gonna go, Liz, I know you're very busy, so I'm gonna go straight into it. And
Okay.
Allow me to say that you look fabulous, and the reason why I say that is because I'm a big fan of you. I've been following you since 2015, and 2015 was a special year. I think September 2015. What did you do during that year? Would you like to share that with the audience?
Sure. So in September of 2015, I took two gene therapies to treat biological aging, the first two gene therapies in the world to do that. So there was a bit of a build up to that. In 2013, my son was diagnosed with type 1 diabetes. And before that, I had been researching and helping educate the world about the use of regenerative medicine. So with my vast knowledge and then my new experience in the gene therapy realm, my company decided to push the button and say enough is enough. We could be sitting on medical cures that can not only help adults, but help children as well. And so we went for it. So we made history in 2015.
Wow, that's amazing. So you the operation that you had was for two genes, right? One was had an effect of telomerase, which is the enzyme that regulates the length of the telomeres, which has the little caps. And what was the other one?
The other one was a gene therapy called follistatin that had already been used in past safety and efficacy for Becker's and Duchenne's muscular dystrophy. So it was being used for a muscle wasting disorder, but we thought that it could also be used for an aging population that gets frailer, meaning they lose muscle mass over time. So everyone eventually gets sarcopenia unless you take something to combat that. This gene therapy would be such a thing that you might take to combat that and increase your muscle mass so that you don't fall down or become incapable of doing the things that often old people become incapable of doing.
Wow, that's great. Well, I'm very fascinated about anything that is genes, genome, epigenetics, and so on. But I wanted to ask you something. So, what do you have available right now, like the general population and the normal person who wants to improve their health? What do we have right now available that people can use to improve their health?
Right. So right now, BioViva cannot offer gene therapies. We do research and development at Rutgers University, and we're designing the gene therapy of the future. So we've spent a couple of years in some animal studies, and we're essentially creating what would be considered a vaccine against aging. So it'll be multiple genes that are used to treat aging, hopefully before it happens to people, but help reverse aging when it has. But we do work with a company called Integrative Health Systems. They're an exclusive partner to BioViva, and we help them by analyzing their patient data. And what they do is they offer gene therapies for regenerative medicine. So it's all done legally under consent between a doctor and a patient. And the things that they offer the gene therapies that I took. So they offer telomerase-inducing gene therapy that lengthens the ends of your chromosomes. They offer the myostatin inhibitor to increase your muscle mass. They also offer Clotho that is for protecting your kidneys against chronic kidney disease and your body against cardiovascular disease. And they offer PGC1 alpha, which helps with mitochondrial dysfunction. It creates healthy, robust mitochondria in old cells. So it's pretty exciting, the things that they're doing.
Wow. So that is actually happening right now with this company.
Yeah.
Wow.
Yeah.
Okay. I'm going to be in touch with them. But but I know that people, well, let's say for everyone out there, I think a good place to start, and correct me if I'm wrong, would be probably doing a genetic test, right?
Yeah, sure. Learn about your genes. I mean, you shouldn't just jump into gene therapy because somebody said that they think that it will help you. You should really research it. You know, you need to become your own best advocate in medicine. I believe in your agency and autonomy to take with your body anything that you want to. I don't think the government should stop you from doing that as long as it doesn't hurt the people around you. Yeah. But I do believe that you should go in well educated. And one way to educate yourself about genes is learning about your own genes, taking some testing, learning about biological aging, taking some testing around that, doing some reading of scientific literature. So I could come on here and I can tell you this gene therapy lengthens telomeres, or this gene therapy increases your muscle mass. But you don't have to take that from me. There are thousands of papers out there, research papers that were done to prove the evidence behind these treatments, and you should go out and read them.
Yeah, no, absolutely. I think, what you said is an important message for everyone is do your own research. And, your health is your health. And there are so many great professionals out there. However, I think no matter where you go and who you put your health to, I think it's always good to do a little bit of research, because your health is probably the most important tool that you have, right? It's the most important things that you have.
It's your most important asset, and we always say it's the world's most important currency. Not only were empires built on the backs of longevity, countries industrialized based on how long their population lives, their general lifespan. But your biggest asset going forward is your lifespan and having more time to create more wealth, whatever that is to you, whether that's, just happiness, spending time outside or money, you certainly should have more time healthy doing that. Because when we start to get sick and die of aging, we are in bad health that costs us, our families, and governments a lot of money. And so, there's a lot of reasons to move forward to try to treat that condition. And these are the therapies, the first line of defense, I believe, that will significantly change how long humans live.
I mean, what you said is great. And there is David Sinclair, there is, I'm sure you know him, and he says something that I think is very profound, that aging is a disease. And I love seeing age as a disease for one reason in particular, because when you see like aging as something natural, you stop fighting, let's say it this way. You give it for granted. There is nothing we can do. It's natural. But since you start seeing aging as a disease, you have a line of hope. It's a disease, and perhaps that can be cured. And I think it's a very exciting time to be alive, because especially in the last probably 10 years, so many exciting things are happening. One of the things is that finally we can actually measure aging. before everyone was talking about, okay, aging, but there was not an official currency for aging. Yes, there was telomeres and maybe, something else, a biological age. But I think now we have something that we can say, okay, biological age can be measured by what is called, correct me if I'm wrong, a methylation clock.
That's right. You've done your research. Yeah, in 2013, I started talking about aging being a disease and nearly got myself kicked out of a couple nonprofits. They didn't believe that. I inherently believe that. I believe that to this day. Anybody who looks at aging can see that it's a clear pathology. It is in fact a disease. And the type of thinking that is around, something being natural and we don't want to treat it. Well, you know what? This type of thinking was around cancer. And it wasn't until the 1960s that the United States government started to fund a cure for cancer, because advocates like me came out and said, you must do this because people are dying. And they said, no, dying of cancer is natural, as part of aging. And now look, because of interventions into cancer, people live decades past diagnosis. And so, so you're right. How would we treat something if we don't know how to measure it? That is the beauty of the methylation clock. The methylation clock is the most accurate biomarker of biological aging right now in the world. It's accurate within 1.5 years of the person's age. That's super significant. And not only that, what the beauty of the methylation clock is that it is a clock that you can actually affect. So we can actually change the outcome with lifestyle or treatments. And that's what we're really excited about doing. We want to see how gene therapies affect the biological age clock. So how does a methylation clock work? Well, it's how your epigenetics are presenting themselves. So if we had a whole room, if behind me I had, that would be against the quarantine standards right now, but let's say I had 10 people behind me and they were all chronologically 65.
Yeah.
Well, why do some of those people go on to dying next year and others go on to living over 100 years of age? It's basically gene expression and genomic instability that really lays rise and increases the mortality risk of the people in the room. So with regenerative gene therapies, what we're trying to do is affect the genome and make it look and act young again, therefore affecting everything downstream from it. That's probably the most simple way to put it.
That's great. And for people at home who are listening, I know that you've done a test before and after your operation, and I think I didn't read that. I read that from a blog, so I'm not sure either if it's correct or not. But you reversed your methylation clock went back of something like crazy, like over 20 years, something like this.
This actually was not a methylation clock. So we didn't have the methylation clocks before I did my therapy. They were still vastly experimental in 2015. So what you're referring to is the length of my telomeres. So my telomeres did lengthen by over 20 years, actually, with the final result that we had in the last test. So, but that's just the telomeres in my T lymphocytes. So that's just my white blood cells. So we can assume that we hit quite a few cells in my body, but probably not every one of them, obviously, So, that's something that we're going back to the drawing board. And actually, I'm planning to take more gene therapy.
Really? Which one?
That's being designed right now by some medical doctors and some researchers, but I'll probably take some more telomerase induction. I will take Clotho, I will take PGC1 alpha, and I may take more follistatin.
Wow. PGC1, perfect. Sorry, I was writing notes. That's amazing. All right, I'm just gonna go back to methylation, just to kind of have an idea. So potentially, if I understand this correctly, so let's say I do and this can now be tested. My methylation can be tested. My methylation clock can be tested. So let's say I do my methylation test right now, and my biological age happens to be 33, exactly my age. And then I started implementing some changes in my life, and then I want to see if those changes in my life are having a good effect or a negative effect. Then I retake the test, and then I see whether my biological age has been going up or down.
Yeah,
Is that
that's
yours?
right. Yeah, that's right. That's what we want people to do. We would like people to take it twice a year, every year, for the foreseeable future, so we can understand a lot more about aging. But we have to understand a lot more about what the people who are taking the tests are
Yeah.
actually doing, because everything from your food to the amount of sleep to the general lifestyle that you live is going to affect that test. The beauty of that test compared to taking like a whole genome sequencing is your
Yeah.
genome is pretty static. It doesn't change. The methylation clock, you can change it. So let's say that you decided to take some extreme diet,
Yeah.
and you're like, I'm only going to eat onions and prunes, or I'm only going to eat meat or something like that. Well, you might lose weight, but are you actually putting years on your life, or are you taking years off of your life? These are the things that we want to find out. So this is what our bioinformatics at BioViva has been set up to do. We created a methylation clock called the timekeeper. We say your
Okay.
timekeeper is here. And this clock is designed, it actually takes the most data points that you can get in a methylation clock. So almost, very few of them are actually understood at this point, but that's the beauty of it. We can understand them over time. So there's 850,000 CPG sites that it actually analyzes.
Wow.
And we want to see what's the difference in the big picture when people take a gene therapy or when they do lifestyle changes, and see if we can actually suss out more biomarkers out of the CPG sites than have been found before.
That's amazing. So that's a service that you as BioViva, so that's available right now for people.
Yeah, people
Okay.
can access that right now. They can go to the website. It's bioviva-science.com, and it's they can buy it. It shows up in a couple of days. It's a beautiful kit, and
Okay.
minimal waste, which I really love.
Thank you.
And you can find out more about you, which is, your most important asset.
So if I sorry, I'm being very selfish. Sorry audience, I'm gonna ask this for me. If I if I order the kit, so then I get the test. The information that I'm gonna get back after the test is basically my biological age.
Right, that's
Okay.
right.
That's great. Amazing. Alrighty. I wanted to ask you also thank you so far. I just wanted to ask you also a couple of questions regarding, you, especially with your company, probably you have seen, and I know you offer a lot of recommendations, the lifestyle recommendations. And I know that, the more we move towards the future, the more we're going to have like personalized therapy. And we just talked about it, any type of therapy would be personalized based on my gene, based on my gut, and another number of factors. However, if there is, would you like to give some general recommendations that anyone, regardless their genome and so on, can apply to improve their health tomorrow? And I would love to be that, let's say, in 3 levels, if it's possible. Something that I see the granted, the normal people that, those things that people know already, but some people never practice, but it's good to remind them. And then the second level, which can be maybe supplementations and so on. And then the third level, which can be probably the more extreme stuff.
Okay. Well, number one, I can tell you, get out and exercise.
Yeah.
Don't over exercise. Don't go too extreme, or else you're just going to bang yourself up. But go out and move your body. And I actually have on my own program. Someday I will actually share it with the world, because it's kind of like a no pain sort of way to get people started and really make them successful in their workouts, not push them so far that they're sore the next day and then they don't want to work out for 3 days. There's a lot of people who like pain around exercise. I don't actually like it, and I can build my body up really strongly. gene therapy or no gene therapy by just practicing doing exercise correctly and in small doses and building up to larger doses, making really successful for people. So go out and exercise, do it every day of the week, and don't push yourself to the point where you're not going to move for 2 weeks, because then you're just going to lose every gain that you might have gathered. I mean, diet, I'm not an expert in diet. I always suggest that people talk to my friend Ray Cronise. He has done amazing work with a lot of famous people, including Penn of Penn and Teller, helped him lose, like a lot of weight and actually keep it off for years. He does lifestyle, and he actually does diet that's healthy for your body. So I would defer that, because I mean, with dieting, losing weight, like I said before, doesn't necessarily mean healthy. Okay. And, so there's a lot of diets out there that are not very healthy. And so eating healthy is the most important thing, and just exercising on top of it. As far as supplements, a woman that I love is Dr. Sandra Kaufman, and she's got a protocol. She's got a book. It's Dr. Sandra Kaufman, that people should check out. And it looks at the hallmarks of aging, similar to the hallmarks of aging that BioViva looks at with gene therapy, except for it looks at the lowest hanging fruit and nutraceuticals that actually do have a beneficial effect. So, no stuff that you don't want with, I'm trying not to say like rude words, but nothing that you don't want to have in your diet or that isn't proven to have an effect. So I would suggest her for diet. And then, where you're going, where we're all going, as long as we can get these gene therapies affordable, is gene therapy. The beauty of gene therapy is you're going to do it once or twice in your life, and it's going to stick with you, and it's going to have the biggest bang for the buck, because it actually is fixing the problem at the nucleus of the cell, making the cell more youthful and healthier. And the gene therapies are just going to get better over the years. So we're sitting on gene therapies now that create regeneration. All 4 gene therapies that we look at extended animal lifespan. Humans live a long time, so we're really excited to see how long our customers live, or Integrated Health Systems customers rather. And we're really excited about that. But that would be the top tier, and hopefully that top tier becomes so inexpensive and so ubiquitous that in the next 20 to 25 years, everybody's just participating in them, not thinking that they're much of a big deal. Because, how we do medicine today, it's called sick care. We wait till you get sick, then we saw your chest open and, operate on your heart and throw some veins from your leg onto your heart and hope that it takes and, saves your life. People think that gene therapy sounds, gene therapy, that sounds really serious. It's a series of injections may keep you from ever needing to have your chest sawn open. The promise of this technology is amazing. There are several gene therapies that are starting in their basic paperwork towards clinical trials for just cardiovascular disease. This area is expanding. We have a database that we're hoping to open to the general public in the next year. We're still building it. If I would have built it, I started building this database actually, I think in 2014, before I started BioViva. I could have put it together in 3 months with what was known in gene therapy. Now we'll be working on this for years, updating it, because there's so much good science coming.
That's amazing. That's great. I wanted to ask you and I love the example that you've done, and I think the more we move forward, the more people would think about gene therapy just as a normal therapy, which it is, because it's very covered by, like you said, is right now at this point in time, there is a lot of science behind it. But I'd like to know, especially for people who are listening, how, I know it would be difficult to explain it in single words, but what actually happens when I do a gene therapy, let's say for my telomeres?
Yeah. So gene therapy is kind of like the ultimate nanotechnology.
Hmm.
It is a very small, you can't see it,
Hmm.
type of technology. And I'll tell you how it works. First of all, I'll tell you how viruses work. Right now,
Yeah.
we're dealing with the corona virus, where we're dealing with COVID-19 or the SARS-CoV-2. But how a virus works is it is inhaled or it gets into your bloodstream and it attaches to a cell and it puts in its genetic material. And then that genetic material uses the machinery of your cells in order to replicate itself. This is an evolutionary machine that is all around us. Viruses are in bacteriophages. If you really want to nerd out,
Hmm.
go and search bacteriophages on the internet, and you will
Hmm.
have you will be absolutely amazed of this great war of bacteria and bacteriophages that happen every day. But viruses in general, what they're really good at is getting into cells and getting their genetic material into cells.
Hmm.
With gene therapy, we use viruses that are not like scary like the COVID-19 virus, but viruses that know how to get into cells, but we take out their ability to get you sick. We take out their ability to replicate. And what we put in is a therapeutic gene. So what are they good at? They're good at unlocking, knocking on the door of a
Hmm.
cell and saying, hey, I want in, I've got some material here. I'm just doing a special delivery to the cell. Well, they deliver just the therapeutic genes. And what happens is the therapeutic genes then go into the nucleus of the cell and they start coding for proteins. So your chromosomes, every cell in your body has chromosomes. And the chromosomes all have genes that have DNA, and the DNA codes for proteins, and that makes everything about you. Okay, so
Yeah.
go look in the mirror. There's even evidence of how we think and how we deliberately behave in the world is vastly because of our genes. So what we're doing is putting in a therapeutic gene, a human gene that you already have, but we're upregulating it so you have more regenerative capacity in your cells. And so we've taken this beautiful thing that nature does to you every year anyway. So you take your own gene therapies anyway
Hmm.
with viruses. We give you the ability to take therapies that are beneficial and healthy for you. And that's pretty much what it's like. So for a patient, most of the therapies, they would just come and they would sit and they would get an IV in their arm,
Hmm.
and they would be overseen by a medical doctor and medical staff. And maybe after 2 hours, they're done. The medical drip comes out and they are observed for a few days. And then they get back to their life and they just do regular check-ins with the doctors to see that everything is okay. But for a patient, it's not very invasive. It's considered minimally invasive.
It's like a normal IV injection. So like
Yeah.
from the outside look of the patients, of course, at the back of the scenes, there is way more happening.
Yeah, there's a lot in the world of the cells. There's a lot happening. It's really interesting. It's really fantastic. But on the outside appearances, not much is happening, and the body really internally isn't reacting to the new gene therapies. A lot of the problems of the old gene therapies has been fixed, so it's unlikely that you would even get a fever or anything. You literally are just going to start to slowly over the next few weeks feel the benefits of the gene therapies.
That's amazing. What I was not expecting is that you need, let's say, top ups. For let's say for the same gene therapy, let's say still for the example telomeres, I'll do it today. I was expect once I upregulate a gene, then what's the reason why I need, let's say, a top up after a few years?
So with some of the gene therapies, so there are 5 regulated gene therapies right now.
Yeah.
Okay, there are 5 that have passed through regulations, and they're a one-time treatment to a lifetime cure.
Okay.
And that's because the amount of the upregulation of the gene therapy that you need is limited. So a follistatin gene therapy, if you do the right amount the first time, you probably will never need it again in your life. Maybe you would in 60 years, just due to cellular turnover. But a gene therapy like telomerase is a little bit different because with telomerase, we're trying to hit every cell in the body. And right now, there's no delivery method that will hit every cell in the body. So could we extend significantly the lifespan of a human or organism with one treatment? Yeah, that's very possible. It's been shown in animal studies that one dose can in fact do that. But what we're trying to do is really break the boundaries of health span and lifespan. So that probably will need multiple therapies. We don't know yet, but I'm willing to be the first person to try that to see if in fact that does have a benefit.
That's amazing. I can be the second person if you want. No, I just wanted to give a little bit of context of people who, because some of the people who are listening are just approaching to this world. So, just to give them an idea of how powerful it is. So we got chromosomes. On top of our chromosome, we got telomeres. Those are those little caps. Every time a cell divides, this telomere becomes shorter and shorter and shorter. To put into a graph, 80 years old children would have way longer telomeres than an 80 years old person. Perhaps the conclusion: the shorter your telomeres, the more you're aging. And there are even some animals that they have a very good telomerase, which is the enzyme that upregulates the telomeres. They have a very big telomerase activity, and those animals, they live for thousands of years. I just wanted to give this context to people who are listening. I'm not saying we're going to live for thousands of years, but what I'm saying is that, just one simple gene therapy like the one for telomerase can have potentially a very huge impact for longevity. And I say longevity because it's not about living forever. It's about living at your best for the longest. So that's that.
Yeah, and I mean, there's so many things that are tied to telomere length. So, let's just consider, do short telomeres in humans mean a shorter lifespan? There's a disease called progeria, and these children are born with short telomeres, and they die of all the diseases of aging, but in their teen years. That is our telomeres associated with lifespan? Yeah, of course they are. They're not a perfect gauge, though, because when they become short, when we're old, they often go into a senescent cell state, and they can stay short for a long period of time. So they're not a perfect measurement, but they're pretty accurate to health outcomes at minimum. So there are a couple ways of looking at aging. So David Sinclair is looking at cell reprogramming, make the cell act young. Well, that's great, and it would be perfect if you also lengthen telomeres, because if you don't, you still have the Hayflick limit. You still have a limited number of cellular divisions. So think about it that way. Reprogramming a cell to behave young would make an organism young. Lengthening telomeres would make it so the organism also had more cell divisions, and so doing both, it would be, the most highly beneficial.
Yeah, indeed, very powerful. And a book that I recommend for people who are listening is called The Telomere Effect, which kind of, I think, explains very beautifully and in a very simple manner what this is all about. Another question I had for you, and I'm going to step back on methylation. Do you reckon are we going to have, do you reckon in a future, maybe just in a few years, a kit that people can use at home? So let's say I can have a low-cost methylation kit that I take today at home, and I get the results right away, and then I can do the same thing in a week, 2 weeks. Like, do you reckon? Because of course they are a great thing, but do you reckon, first of all, they will get cheaper? Second of all, I think it's very worth doing it right now. But do you reckon, will they get a little bit cheaper? And do you reckon, will they get even faster to track the results? Something that people can do themselves at home?
Yeah, all of this technology will get cheaper and faster and better, and companies will come in and have more interest. Maybe companies like Apple and Microsoft will come in and have more interest in actually getting your real-time data right, right where you're sitting, because there's a lot of benefits for health and by understanding where you're at. Right now, they're pretty expensive today. With our kit, it has very low profitability. Actually, we made the kit to use in
Yeah.
patients before and after gene therapy. It's synonymous with getting your whole genome sequencing done. So one kitting company might take 3,000 sample CPG sites. We take 850,000 because we're trying to look at everything. So the cost of doing that test just on one person is almost the cost of our kit right now. So yeah, it's not a great, but we don't do things for profit. We do things because they're the right thing to do. And so, but even that technology in the next few years will be less expensive. So, we are hoping, and that's the hope of the whole industry, is to make things as less expensive, at as little expense as possible to the consumer. Because if you have a kit that's $500, you have very few people who are going to buy it. If we could offer the kit for $99 and had a lot of people buying it, even if we made $2, we'd make more money. And of course, we would love to do that. Right now, with the technology we're using, we can't do that. But in the next few years, yeah, we should be able to easily do that.
Yeah, and I'm optimistic about this. I remember just a normal gene sequencing would be, thousands of dollars, and now is hundreds. So already a big jump. Do you give with the methylation kit? I know that because people are gonna ask, do you also get things like I don't know if you are a fast caffeine metabolizers and MTHFR. Do you see also these things, or that's separate for?
No, those things are what you would find in your genome. So those would be readings that you would find due to the association of certain genes in your body. With the methylation kit, you're going to find out different markers than the ones that you would there. And so that's why you always want to, your pharmacodynamics, you want to get your genomes sequenced as well. You don't want to just do a methylation kit. You should know as much about your genes as you possibly can. Another thing, remember, every test out there is not the same.
Yeah.
So if they have low times analysis, you might only pay a few $100s, but the accuracy might be pretty low. So, my suggestion is pay a little more and at least get some sort of research grade readout. And those are still more expensive, but they'll tell you more accurately what's actually happening with your body.
Would be too much for me to ask you for maybe company recommendations for genome test?
Oh boy, that is ever changing. You know what? I will get with my team and see who's the best, who's the hottest for the best price, and I'll have them get back to you about that, because that's ever changing. It seems like even recently some companies went out of business. So
Yeah.
the problem is like you have a really good company and then they say, okay, we're just going to go for the data. We're going to offer this cheap, inefficient, or free, and we're going to go for the data because the valuation on the data is so great. And then that didn't really pan out for a bunch of companies. And those tests are actually really expensive to run if you want an accurate test.
No, that's true. And yeah, I know that some companies they don't do for profit. They literally cover the costs. Some of them, they also go slightly in a loss with the hope of making them profit with the data. Talking about data, I know we're going a little bit too far, but I just want to open a bracket and then close it. Do you have any, because I know it's a common concern for a lot of people who wants to get like a genome test. Do you have maybe any recommendation on how to protect your data if you want to, or if that is even a reason of concern if I going to get like a genome test?
Yeah, well, there's two things. You should take care of your needs first. But okay, so you should go with a company that will protect your data. That if you say that you don't want the data used, that they will not use it. We are one of those companies. But you should definitely use a company that you feel comfortable with. But then I'm going to go ahead and flip this, because the truth of the matter is there's not a lot right now in the human genome that is outside of our grasp, that's outside of our parameters. If you have something that is catastrophic, as a health community, we probably knew it soon after you were born. It was probably something like sickle cell anemia or hemophilia B. The more people are open with their data and realize that there's not much to hide in the average human genome, for the most part, we know how you'll die. A third of you will die of cancer, a third of you, more than a third of you will die of heart disease, and the rest of it will be dementia, accidents, kidney failure, and COPD. And those are the biggest killers. So there's not much to hide out there, guys. The thing is, the more data you share, the more we can solve the problems faster. So we do suggest that you share your data for research and let us use it for research purposes. That's the way that we can make precision medicine faster. It's kind of like, the whole thing where, people became very sensitive about what was on their computer and what they were surfing on the web. But the thing is that most people are, smack dab predictable. Humans didn't turn out to be that different from each other. There a lot of them are all surfing the same things, and so there's not really much to hide in that data. And and if there is an outlier, either you're a really cool person or you really need some help. So hey, only you could know that. So the health data is the same thing. The more you share, the more we understand about humans, the better we can actually serve and cater to what humans need. And in the case of our company, that would be better health.
That's great. I want to also ask you, what's BioVault? I know that you have an offer. That's another of your products. So you got Timekeeper to measure your methylation clock, but you also have BioVault. And did I pronounce that correctly?
Yeah, it's called the BioViva BioVault. We're excited about this product and this project because it's going to expand exponentially. We want people who are biohackers. We want people who are just, doing basic interventions or nothing with their health participating in this. Again, you can share your data or you don't have to. If you don't want to share your data, you don't want to participate like that, consider it like Dropbox for your health data. Yeah. It's a place where you can keep everything. So let's say, you've gotten a full genome sequencing in one place. Let's say you've gotten a methylation test in another place. Let's say you've gotten your microbiome analyzed, and then you've got all of your medical records, and you're having to log in to all of these different places to access your data and have them store it. We want you to put it in one place. And then if you will allow us to, we will actually use that to help, cure aging and disease. And so think of it again as Dropbox for your health data. And then outside of that, we hope to, over the next few years, start to give you assessments of, correlations between your data. Let's say you have your microbiome and you have your methylation and you have your genome. We want to tell you, with the newest science, the newest research papers out there, what your risks are and what your health benefits might be for having the certain combination that you have. So, also, the BioVault, everyone who gets a Timekeeper gets a year free of BioVault because that's where you get your results. You get to access the BioVault, you get to go in and put in your information, and you get to see your results right there. So it's a HIPAA compliant, GDPR compliant system, and we're really proud of it. And it's still vastly, under development. It's going to be changing a lot over the years.
No, that's great, and I know, guys, you've been having some great progress over the year. Oh, that's amazing! That's amazing news. So, where people do you also serve in Australia or like internationally, or just in the US?
We can send kits all over the world. So people can use the Timekeeper and the BioVault from almost anywhere in the world. Now, if you're in a country that has specific regulations about health testing kits coming in and out, you might want to check that before you order it. But we haven't had a problem so far getting it to, far reaches. we're pretty amazed of all the variety of different countries that have people in them that are interested in our kit.
That's amazing. I'm gonna ask you one more question, and then I'm gonna let you go. um, I mean, you're welcome to stay as much as.
Oh, no, I would love to stay, but I have to tell you, I am really tired today and I'm not myself, and I'm going to tell you why.
Tell me
It's not
why.
because of gene therapy. We got a new puppy last night.
Oh my God! Really?
And
What's?
the puppy is so cute. I wish he was here, but he's in another room sleeping. And I'm so glad he's sleeping because he came straight from a farm to the house and he howled all night, and everyone was so
Oh.
sad. We were up with him petting him. Oh, it's okay. And he was, oh. So I'm particularly tired today, so I'm sorry to say that I'm not my best for you today, but
That's
it's for a good reason, for a good cause.
that's so cute. That's so good. You look great, and you know you're sharing great content anyway. So that's still good. But I know the feeling. I have a cat, which sometimes during the interviews just pass by and people can see in the camera, and right now it just teasing me. But
Yeah,
yeah,
I've got one right over here, and actually, she came in, and that's why I kept looking up because sometimes she'll jump right at me, and she's done that before. So I was like,
don't do
"Layla,
it.
don't jump at me."
And they love interviews. I mean, especially
Yeah.
during interviews when I'm on the phone, she just goes around and trying to disturb. But now she's been good. She's been behaving better than usual. Um,
I think they wonder what we're doing because a
yeah,
cat only gets loud when they really have to. So they're probably like, "Why are you going meow, meow, meow to your computer?"
I know, I know. She's looking at me right now. Yes, we're talking about you. We're talking about you, Bagheera. Um,
Oh, thank you.
Bagheera, yeah, she's black. She's all black. And when I took her, she's very little, but she was very scared, so she was always hissing. So
Yeah,
black, Bagheera, like the Jungle Book. It was an
I love
obvious,
that.
it was an obvious choice. Um,
What an honorable name.
yeah. Yes, my question. I'm actually curious because I'm very curious to know the mindset of people, especially in your space. Um, do you reckon how utopistic it is to have a world where a 100 years old person looks like a 50 years old person or 60 years old person? Do you reckon is
Oh,
utopia, or do you reckon we have a line of hope?
oh, yeah. I mean, I think that that's absolutely obtainable. I mean, actually, okay, one thing that we did when I started this company, we went back and looked at historical perspective. I mean, most of the pictures of Charles Darwin, he was only 40. I mean, people didn't have the type of health, sanitation, immunizations, antibiotics that we do. And people who suffered from a lot of diseases, even in our parents' age, ended up dying younger because of conditions that went with hand in hand with rheumatoid, not rheumatoid arthritis, but some of the rheumatic fevers and things like that they took instead of being immunized against. So we already live younger and better today. We already benefit vastly from technology that seems almost magical to people 100 years ago, and we're looking better than ever. We know about the sun, and unfortunately, we didn't in my generation because I'm almost 50, and
What?
I mean, we laid out in the sun
Really?
until we would be like, oh gosh, I mean, we were like so brown. I mean, our clothes glowed on us because we were practically rain. So even generations now will do better. But what we'll do now is we'll use these therapies and we will regenerate skin. My skin looks better now than it did before I did the gene therapies, and hopefully we'll get better and better output from the therapies as they get better over the years. Because regenerating all of your organs. I love makeup and I love doing my hair, and I'm I like being a woman, you know, and I like all of those things. And but I'm actually not a vain person. I don't think. I don't think of it as vanity. The gene therapies, I think of them as survival, and survival is smart. Vanity can be smart or dumb depending on how it's used. But I you know, gene therapy isn't just about being like, oh, I'm 20 and, you know, full of foolishness. It has nothing to do with that. It's about being smart. It's about living long and getting even smarter.
I agree. Great answer. And I'm totally with you. I mean, who doesn't want to be that bad? And even physically, right? Especially um with the other gene for the muscles. I mean, is it's only normal that people wants to be healthy for longer. And sorry, I'm gonna be a little bit controversial, but is I mean, some people are gonna hate me for it, but it just sucks being I don't know, 90, 100. And, there are so many people that are doing very well at their age and not be able to do the things that gives us the most fulfillment in life. Like, spend time with our parents, traveling and being independent. And, if I think about it, it's scary that a vast majority or a big percentage of people that are over 60 and maybe they get to live up to 90, that's 30, 67 years, that's 30 years, they spend 30 years of their life, in a condition where they are maybe not independent or
Yeah.
and that's scary.
It's true.
Yeah.
So statistically, today, 30% of your life will be spent in ill health, in chronic disease. Hundreds of millions of people today have chronic disease. So I don't want people who are listening to this today to aspire to be healthy for your age 90-year-old. I want you to aspire to be actually healthy 90-year-old. And that means that we have to bring out the new medicine. We need to regenerate bodies and keep them healthy. And we don't want you to live old longer. We want you to be as chronologically old as you would like to be, but absolutely robustly, youthfully healthy. And so the type of human that we are creating for the future isn't something that we've seen before, because a 20-year-old, if you look at the biology, they're accumulating damage.
Yeah.
A 30-year-old has accumulated enough damage that we could probably, by looking at you and doing testing, we could understand what your shortest fuse was, what you'll probably die of already. You won't
Wow.
die now, you'll die later, but we could see, do you have atherosclerotic plaque buildup? Do you have mitochondrial dysfunction? What systems of your body are falling apart? So we want to create the first body that stays in homeostasis for as long as possible so that people have a meaningful life. I mean, to me, there's only dignity in progress. And so you don't have to choose for gene therapy. You can, if you find meaning in life by getting old and degenerate, and I don't mean to be rude, it can be a beautiful process for some people. And if that's how you want to go and let go of your life, and you find meaning in that, that's fine. I don't. I find meaning in progress. So if I died because I participated in therapeutics that were cutting edge, that's my choice, and that to me still has more meaning than not trying at all. And today these technologies are proving safer than ever. I mean, lots of people are taking them, and we're seeing really good outcome and not a negative outcome. And so hopefully this type of technology just continues to develop through several biotechnology companies that are working on it, and the world becomes more interested and participates, because I would rather you be alive and having a good time with me than not.
Thank you. I have to say I have a deep admiration for what you do and deep respect for what you do. Like,
Well, thank you.
you are very inspiring. For people who wants to get to know a little bit more about you and about your company, and guys, if you're listening, you should, because there are, just go on the VivaBev website, especially in the FAQ. I love that page. You state a lot of very interesting things like overpopulation. Oh my God, if I'm not gonna die, what's the overpopulation problem? And you explained that very clearly on the website. But for people who want to know a little bit more, where they can find more about you and your company.
Well, outside of the website, you can go to, I think that Adam Alonzi has done a great job putting together the BioViva YouTube channel. If you like to look and listen to what's going on, and that's a really good place to go. You can go and check out some other media. We've been around for a long time. We've been in everything from the London Times to National Geographic. Go and do a search and find some things that we've done. But I think the best of what BioViva has done is actually yet to come. And so, I hope that you stand with us to the future and help us take this march against biological aging and childhood disease, and, really help us have an impact and work together. We're vastly a company about people working together. And like I said, I think the best is yet to come. I think there's some stuff to read, and we talked about that, doing gene therapies and other people participating in gene therapies. But the future is, I'd say the next 10 years are what you want to keep your eyes on.
That's great. Thank you very much, Liz. You've been truly inspiring, such a lot of content, and I loved this interview. Thank you. Thank you very much. Hey there, thanks for listening. Before we conclude, I'd like you to remind you something very, very important. This episode, as well as this podcast in general. Hey there, if you haven't heard about Anchor, it's the easiest way to make a podcast. Let me explain. It's free. There's creation tools that allow you to record and edit your podcast right from your phone or computer. In fact, I'm recording this from your phone right now. Anchor will distribute your podcast for you so it can be heard on Spotify, Apple Podcasts, and many other platforms. You can make money from your podcast with no minimum listenership. And it's everything you need to make a podcast all in one place. So go ahead, download the free Anchor app or go to anchor.fm to get started. It's for general informational purposes only and does not constitute medical advice. Listeners should not disregard or delay in obtaining medical advice for any medical condition they may have. Please, if you have any medical condition, consult your physician first. Disclaimer given, I would love for you to subscribe to this podcast and to leave me a review. That will help me a lot. We're just starting out. We have already a lot of great interviews down the line, which you don't want to miss. So hit the subscribe button so you will get notification for the next exciting episode. I'll see you next time.